And class 9 circle theorems part 3 continue. Part 1 please comment. Part 1 introduction to circle. Part 2 two theorems related. The perpendicular bisects the chord. If it is a perpendicular, the line perpendicular to a chord bisects it. If a line to a chord bisects it, it will be perpendicular. Theorem 1 and Theorem 2 converge to each other. Theorem 3 is related to distance. If before starting, suppose these two chords are equal. If these chords are equal, they are equidistant. If they are equidistant, and if they are equidistant, they are equal. What is the meaning? Chords equal means this chord is equal to this chord. Here distance means perpendicular distance. This one distance, this distance. Distance here means perpendicular. Perpendicular distance. यहाँ distance भन्नाले सेन्टरबाट कर्डमा ड्र गरेको perpendicular भन्ने बुझौँ. If two chords are equal, their distances are equal from the center. Chord equal छ भने सेन्टरबाट त्यसमा ड्र गरेको perpendicular equal हुन्छ. अब equal छ, suppose two chords are equal, their distances are equal. Suppose these two chords are equidistant. This distance is equal to this distance. So these two chords are equal. If chords are equal, they are equidistant. If two chords are equidistant, they are equal. यसको लागि you apply theorem. Apply one theorem, Pythagoras theorem, one thing. To पढ्नु भन्दा Pythagoras theorem one thing. Another, if it is perpendicular, it bisects. Perpendicular हो भने bisect गर्छ भनेर चाहिँ हामीले बुझ्नु पर्ने हुन्छ. So I write down the question. First of all, I write down question. Theorem number 3 is, if two chords are equal, they are equidistant from the center of the circle. What does it mean? What is the meaning of this sentence? If two chords are equal, then they are equidistant from the center of the circle. It means two chords are equal. What are given? Circle is given, center given, distance means perpendicular distance equal. So the given condition is this. In a circle, this is the circle, this is the center. Two chords are, if two chords are equal, suppose this is one chord, this is another chord, name A, B, C, D. Two chords are equal. Then they are equidistant from the center. तिनीहरूको distance चाहिँ सेन्टरबाट के हुन्छ? Equal हुन्छ. तिनीहरूको distance means here perpendicular distance. You can name any A, B, C, D, E, F or P, Q or M, N, any. I suppose M, N. What is given? Just see. If two chords are equal, which are two chords? AB is one chord, CD is another chord. Equal. They are equidistant. Which are equidistant? AB and CD are equidistant. From where? From the center of the circle. O is the center. So, what the given condition is this. See, here, this is the question, and from the figure, you have students should write down, draw a diagram, draw a circle, center, two chords, their distances O, M and O, N. गिभन कन्डिसन के हुन्छ एबी र सिडी दुईटा कड हो ओ सेन्टर हो डिस्टेन्स भन्नाले परपेन्डिकुलर ओएम ओएन इक्वल हुन्छ प्रुभ गर्नु छ सो व्हाट इज गिभन कन्डिसन इफ टू chords are equal they are equidistant from the center equal given equidistant to prove so given condition is O is the center of a circle is any circle then what is given two chords are equal chord AB equal chord CD that is also given chord AB equal chord CD and equidistant means OM is perpendicular to AB at M and ON is perpendicular to CD at N. What is given? The given condition is given condition OM is perpendicular to AB, chord AB, and ON is perpendicular to chord CD. Here distant भनेको दूरी. It means perpendicular equal. Two chords are equal, perpendicular OM and ON. To prove two chords are equal given. Which are equal then? Which are equal? They are equidistant means equal in distance. Which are equal? Perpendiculars are equal. Distances are equal. It means OM equal ON. Perpendiculars are equal or they are equidistant. Chord AB is equal to chord CD. To prove their distances OM and ON are equal. To prove construction. What is the construction? Since there is, you don't need to draw any other things. I just write on. Draw either AODO or BOCO. BO and CO are joined. Can you say, students, dear students, can you say why BO and CO are joined? Can you say, can you guess why are they joined? And what theorem, what fact can you use? Right angle, hypotenuse, side. Right angle, hypotenuse, side. Right angle equal. AB bisect, OM bisects AB. ON bisects CD. So, if AB and CD are equal, then BM and CN are also equal because the perpendicular drawn from the center of a circle to a chord bisects it. Theorem 1. So, construction BO and CO are joined. What fact can you use? Can you write OM equal ON? No. Why? Because they are to be proved. त्यही प्रुभ गर्नु छ. त्यही प्रुभ गर्ने कुरालाई यो टु प्रुभ छ यो लास्टमा लेखिन्छ. सो व्हाट फ्याक्ट? राइट एंगल हाइपोटेन्यूज साइड एक्ज्यूम or fact. Apply RHS, right angle equal, hypotenuse radius, BM equal CN. It is suppose given. It is given. So it is you can easily prove it. See, let me rub it. Can you say what? Prove what fact? RHS fact. See, this is the diagram. Circle AB chord, CD another chord. See, AB, O center, perpendicular, M perpendicular, OM perpendicular, ON perpendicular, construction Now, facts and reasons. What fact? In what triangles? In two triangles BOM and CON. In triangle BOM and triangle CON. What did I say? I said please apply RHS fact. Right angle, hypotenuse, side. Right angle, hypotenuse, side. Can you say which is the right angle? BMO. Angle BMO equal angle CNO. Angle CNO. See, in some books, the angle is written in this way, but here it is in a right angle. Hypotenuse is BOCO. BO equal CO. Right angle, hypotenuse. Why right angle equal? Both 90 degrees. That is given. Distance. Here distance means perpendicular distance. BO equals CO. Why? Radii of the same circle. See, singular radius, radius singular, and its plural is radii plural. Singular radius 1, radii 2 or more than 2. Radii of the same circle are always equal. There are so many radii, 2, 3, 4, 5. All the radii are equal. Another side is also equal. Here students can write in another point, but I write directly BM equals CN. You know why? BM equals CN. Why can you write BM equals CN? Because there are two reasons. Number one, AB equals CD. One reason, another OM and ON bisect AB and CD respectively. Theorem 1. Theorem 1 says that the perpendicular OM is the perpendicular to AB. Therefore, OM bisects AB. It means AM equal BM. ON is perpendicular to CD. So, ON bisects CD. It means CN equal DN. But one thing, since AB is equal to CD, you can write AB equal twice BM and CD equal to CN. AB and CD are equal. So 2BM equal to CN. So here students can write one more point yourself. Number two, here it is rough to understand. Number 2, they are congruent. Triangle BOM is congruent to triangle CON. Fact, right angle hypotenuse side, fact or axiom. From RHS fact, triangle BOM and triangle CON are congruent. Why? Right angle equal. Hypotenuse equal, because they are the radii of the same circle. Since AB equals CD, half of AB is BM, theorem 1. Half of CD is CN, theorem 1. Therefore, these half sides are also equal. यदि AB र CD इक्वल छ भने AB को हाफ BM र CD को हाफ CN पनि के हुन्छ, इक्वल हुन्छ. Number 3, two triangles are equal, congruent. Then which are equal? Since OB equal OC, BM equal CN, which side is left? के side बाँकी छ? You first equal first, second equal second. Two triangles are congruent. So OM equal ON. OM equal ON. Reason? What is the reason? Being corresponding sides of the congruent triangles. See how they are equal. BM equals CN, BO equals CO. Then what side is left? OM equal ON, being corresponding sides of the congruent triangle. Okay. One more thing. Can you write O angle OBM equal angle OCN? Yes. OM opposite. OM opposite angle MBO. ON opposite angle OCN. Two sides are equal and their opposite angles are equal. BM equals CN. BM opposite angle this. CN opposite angle this. That means angle BOM equal angle CON. Corresponding angles are equal. Corresponding sides are also equal. Now, quick revision. Equal chords are equidistant. Means if two chords in a circle are equal, their distances from the center are also equal. It means O is the center of a circle. AB and CD are two equal chords. OM is perpendicular to AB. ON is perpendicular to CD. To prove OM equal ON, construction BO and CO are joined. Why? To prove the two triangles are congruent, and after they are congruent, you can easily prove OM equal ON. What fact? Right angle, hypotenuse side. Right angle, BMO equals CNO. Right angle. Because it is, you can't add right angle. Equidistant means perpendicular. Right angle. Hypotenuse OB equal OC, being radii of the same circle. And side कसरी equal भयो? AB equal CD. See, AB equal twice BM, CD equal twice CN. But AB and CD are equal. Therefore, BM and CM are also equal. Apply right angle, hypotenuse side. So, two triangles are congruent. Then OM equal ON. So, you can easily write equal chords are equidistant. Equal chords are equidistant means if two chords are equal, their distances are equal or they are equidistant. So this is theorem 3. Now another theorem related to this. Theorem 4. Either you can write theorem 4 or you can also write converse of theorem 3. The meaning same. Converse of theorem 3, theorem 3 को उल्टो अथवा त्यसको विलोम भनौँ न उल्टो. गिभन चाहिँ टु प्रुभ गिभन or theorem 4. Theorem 4 or converse of theorem 3. I will write down the statement. What is given in theorem 3? In theorem 3, just remember, theorem 3 chords are equal. Their distances should be equal. Here, two chords are not equal, but their distances are equal. Remember, here chords are equal, theorem 3, but in this, chords are not equal, their distances are equal. So what is the statement? Can you write the converse statement of 3? 3 chords which are equal are equidistant. Theorem 4. Equal chords are equidistant. Theorem 3. Now I write if two chords in a circle are equidistant. Distant means equal in distance from the center. They are equal. what do you mean by they? Here they means chords. If two chords in a circle are equidistant from the center of the circle, then the two chords are equal. What is given? How to write it? Which is given? If the given condition is two chords in a circle are equidistant from the center. So, given condition is this. The given condition is make a circle, center, two chords are equidistant. Say with equidistant, a little bit convenient. One chord, say another chord. These two chords are equidistant. O, A, B, C, D, say M, N. These two chords are equal, but chords are not equal. Sorry, chords are equal. Theorem 3, their distances are equal. Theorem 4 or converse of theorem 3. Here converse means given is to prove is given. If two chords in a circle are equal, sorry, equidistant from the center, they are equal. Which are equal? Can you say which are equal? Chords are equal. So given condition is O is the center of a circle. O is the center of a circle. OM is perpendicular to chord AB at M. In the same way, ON is perpendicular to chord CD at N. O बाट AB मा perpendicular draw गरेको छ. It is perpendicular also given. And another thing, the perpendiculars are equal. Distances are equal. OM equal OM. Distance of AB is OM. Distance of CD is ON. That means OM equal ON given, because they are perpendicular. Both are perpendiculars. Here equidistant means perpendicular distance. What is given? Center, chord AB, chord CD. This perpendicular OM on AB, ON on CD at N. OM equal ON. What is to prove? In theorem 3, to prove is chord AB equal chord CD. In theorem 3, given is AB equal CD, chords are equal. To prove OM equal ON. Theorem 3, to prove is given AB equal CD. To prove OM equal ON. But converse is OM equal ON. To prove AB equal CD. What is the construction? What construction? In the same way, you can join BO and CO. BO and CO are joined. And what fact can you use? Can you say what fact? कुन fact लगाउन सकिन्छ होला? हेरौँ त राम्रोसँग. ON equal ON already given. BO equal CO given. Right angle given. Hypotenuse given. Side also given. Right angle given. Hypotenuse given. Side also given. From RHS, triangle BOM and CON are congruent. And apply what? What fact? Apply RHS fact. Theorem 3, RHS. In theorem 3, BM equals CN. But in theorem 4, OM equal ON. Apply RHS fact. Now, A, B, C, D, OM, ON. Proof. Proof is this. B, C, D, O, M, N, construction, what is given? Right angle given, hypotenuse given, side also given. Apply RHS fat. Fats, reason. Fats. Fats can also be written as statement. Fat like statement. Same meaning. Fact number 1 in triangle. Uh, Sorry, here I think I have written AB here. इसे लिखे वाला शायद मैंने QNC वर्जन. I have written AB and CD. See, in triangle BOM and triangle CON, can you apply RHS fact? Right angle. Which is right angle? BMO equal angle CNO. Both 90 degree. Why 90 degree? Distance equal. Distance means perpendiculars are OM. Perpendiculars means right angle equal. Hypotenuse BO equal CO. Why? Why hypotenuse equal? Radii of the same circle. In others, we can write this way. Right angle equal, hypotenuse equal, distance also equal. Right angle, hypotenuse, side. Right angle, hypotenuse, side equal. Now side, which sides are equal? The statement says if two chords are equidistant, দুইটা chord হলো equation, AB and CD are equidistant, not equal. Equal হয় না, distance equal. It means OM equal ON, it is given. Now two triangles are congruent. Triangle BOM is congruent to triangle CON. Fact RHS fact. If two triangles are congruent, then can you write BM equals CN? Can you write BM equals CN? Yes. Corresponding sides. Being corresponding sides. If OM is perpendicular to CD, OM is perpendicular to AB, ON is perpendicular to CD. OM bisects AB. It means BM equal M, CN equal TN. It means multiply 2BM equal 2CN. From fact 3 multiplying by 2. Twice BM को double AB. AB equal CD. Why AB equal CD? Because BM equal CN. BM double is AB. CN double is CD. Because OM and ON bisect AB and CD respectively, bisect because they are perpendicular. Perpendicularly bisect गर्छ. Perpendicular drawn from the center to a chord bisects it. OM bisects AB and ON bisects CD. So since BM and CN are equal, BM double AB, CN double is CD. So chord AB equal chord CD, QED, chord erat demonstrandum. Theorem 3. See, theorem 3, if two chords are equal, their distances are equal to 2. But theorem 4 converts two chords which are equidistant from the center of a circle are equal. It means if two chords are equidistant from the center, they will be equal. What is given? The given condition is circle O is the center, chord AB and chord CD are given but not equal. OM is perpendicular to AB, ON is perpendicular to CD, they are equal, OM equal ON. Now BO and CO are joined. Prove triangle BMO and CNO congruent. From right angle equal, hypotenuse equal, side also equal. From right angle hypotenuse side fact or axiom, triangle BMO and triangle CNO are congruent. After showing the two triangles are congruent, so BM equals CN. BM equals CN. Corresponding sides what? Of congruent triangles. Corresponding sides of the congruent triangles. Fact number 2. BM, the BM multiply by 2. From fact 3 means multiply fact 3 by 2. 2 ले multiply करनी. Twice BM equal twice CN. Twice BM means AB. Twice CN is CD. It means if AB is 20 cm, it is 10 cm. If it is 10 cm, it is 20. 10 cm, it is also 20. So if half parts are equal, then the full parts are also equal. That means if chords are equal, their distances are equal. Theorem 3, Theorem 4 is as follows. If two chords are equal in distance, or if the distances of two chords are equal, the chords will be equal. Chord equal हुँदा distance equal हुन्छ. Theorem 3. Distance equal छ भने दुईटा chordको distance अर्थात OM र ON equal छ भने ती chordहरू equal हुन्छ. Here distance means perpendicular. Here don't be confused. Distance means here perpendicular or height. Here perpendicular distance. Always use perpendicular distance. The similarity between them is chords equal, RHS fact, OM equal ON. Theorem 3. But here OM equal ON given, two triangles are congruent, BM equal CN, so AB is equal to CD because OM bisects AB, OM bisects CD, BM equals CN, double of BM AB, double of CN is CD. In this way, you can prove the theorem by applying RHS fact.